Hey guys, today I'm setting up to do a project for my dad. So he has bought 3 outdoor temperature sensors over about the last 3 years, and all of them have lasted about a year, and that's it. And so I am going to try to build for him an outdoor temperature sensor which I try to make more reliable than only lasting 1 year. So as I was at Goodwill a few weeks ago, I saw this clock and I thought, that might make a really good display for a temperature sensor. So I could have 1, 2, 3 digits and then a decimal point in the last digit. So that would give me up to, to measure over 100 degrees. But then also, if we ever got negative temperatures, I could make this a minus sign and then whatever the temperature is if it was negative. So I'm going to take this thing apart and see what I can get out of it, if I can use the display or not. And then I'll also want to try to use these switches, because my plan is to make a temperature sensor that's outdoor and one that's inside, and have a switch that he can switch back and forth between the two. And then he also likes to have a minimum number, so a minimum temperature for the day. And so I'll have another switch that he can switch to see the minimum latch temperature for that day. Okay, so there's the clock, so that'll be the display part, and then the interface, so the switches. And then I bought these, so these are DS18b20s, and so this is I think a common one-wire temperature sensor, and I've used these in the past. I have a temperature logger that has been running for about 5 years now using these, and so hopefully these last a while. And then to do all of the computations and stuff, I bought an Arduino Nano. I've never used one of these before, so I'm going to be coming up to speed on how to do it. I have programmed microprocessors before, microcontrollers, but I've never used the Arduino system. But I don't want this project to take too long, and so I thought buying an already built board, which this is, if you guys have never seen this. So this is a pre-populated circuit board with the processor, which is that thing, and then whatever else to make it run. So that's better than me designing a PCB or printed circuit board and then soldering on all the components, which that turns into a lot of work. And I'm after lower complexity, not as much work, but I still want it to be highly reliable. So those are the components. Now this is just a breadboard that I use to run experiments on. And one of the things that I want to find out about the clock is how they drive the LEDs. And so I'm going to use my light sensor that I rigged up in last week's video to check out how they're driving the LEDs in the display of the clock. Okay, I'm going to see if I can do this without making a mess here. So I want to hold the... There we go. So I'm holding the clock over the light sensor, and I can see that they clearly drive it. So if you remember before from last week, when the light sensor is detecting more light, it conducts more and therefore the voltage goes down. So pretty sure they're driving that at 60 Hertz. And they're driving it for about 6 milliseconds. Okay, so the display is LTC18501A 1P. I think I'm going to need to look at that up for a data sheet to see how to drive the LEDs. Okay, looks like I can get it from this one. There's a PDF. Nice. This looks just like the display I have. So it's a 24-hour display. Here's all the connections. Oh, and a wiring diagram. Cool. I'll use this later. And then it's got just a transformer that goes to the circuit board. So I can probably use a linear regulator for powering the Arduino. Okay, so this is going to be kind of a longer project. We'll take a few videos. Hey, if you like these videos, subscribe. I'll make more. Bye.